today I'm joined by Paul Jones, the founder of MTD CNC and a resident machine tool expert.
Oh, I don't know, not so sure.
Debatable maybe. And I'm also joined by MTD's Gio Albanese, who specialises in work holding. Well, we'll find out about that throughout the show, put into the test. So today's show will consist of 3 sections of work holding solutions and new innovations for milling machines, so VMCs, horizontal machines and 5-axis machines. There you have it. So we'll start with the solution for 3-axis machines. Guys, welcome. Before we get on to business, so Paul, just so the audience know in advance, any gags for us today?
Yeah, they're all here.
Right, don't switch off, please, guys. Please do not switch off. And Geo, what can our viewers expect from today's show?
Well, today's show is all about how you can maximise your efficiencies on all of your machine tools through work holding. I think that there's lots of ways in which it can be achieved. I think that when you're doing 3-axis work, or on a VMC especially, a lot of the work that gets done on a VMC can be low volume work, and subsequently setup time is the killer, especially if you've got continuous one-offs. You're continuously setting the machine and the spindle is continuously down. So eradicating that setup is key, and this can be achieved by 0 point, which is a really easy way to eradicate setup time and give you instant repeatability in doing the setup off the machine. So when one part's finished, the other one is ready to go straight on. But even with some of the other solutions that we're going to be looking at throughout the show, different innovative work holding solutions in which will enable you to machine, not to machine soft jaws. And there's so many different solutions to it.
It's inventory as well. It's about having all the pieces. Do you want lots of different clamping systems all over the place, or do you just want one that can manage a variety or a plethora of work pieces, which is what you want, though. You want something that can manage a lot of your components with versatility, and I think that's the biggest thing with work holding, and speed of change, and of course repeatability to make sure you can produce precision results.
But also, we've mentioned at the top of the show sort of reduction or eliminated vibration, but also part of this is cycle time. We talk about cycle time on machining, but part of that cycle time really is changing those things over, changing work holding over all day, every day.
I think when you look at cycle time, but sometimes increasing the cycle time can be a good thing too. And what I mean by that, so if you're utilising the machine envelope and presenting more components to the spindle, and you're doing several components instead of just one, then you're using the same tool without having to tool change it several times. You're reducing cycle time per part, but increasing the complete cycle time. So there's different ways to look at it, and ultimately reducing the setup time is increasing spindle uptime, and that is the key. And then when you've got kind of you mentioned eliminating vibration, for me that is probably the most important part of having a good work holding solution, because the benefits that you get from that are spindle longevity, tooling longevity, better surface finishes, being able to use the machine tool that you've bought to its maximum capabilities, feeds and speeds. So they're massive.
And cycle time isn't the amount of time you spend on your cycle at the weekends.
Clearly not a lot. Don't start on that.
So because you want to increase that, not reduce that.
Yes, I know. I will do. Yeah,
and vibration he talks about is different too.
Settle down. Right, we get distracted. On to our first video. This is from Tame. It's an innovation for 3-axis machining.
So we're looking at many work holding solutions for 3-axis machine tools, but I'm going to go and talk to a man that's designed his own. David, now tell our audience about a work holding solution that you've designed specifically for 3-axis machine tools.
Well, hello Geo.
Hello,
and welcome. Right, this particular range of products is designed specifically for simple work on 3-axis machines. It can give you any angle. You can produce a 5-axis part on a 3-axis machine using a combination of our multi-rise and multi-rad products.
And does this include the 0 point base plate?
It mounts to a 0 point base plate, but we can do a slight modification and add it to a slipper plate or just clamp it down.
So talk us through this particular solution and how and why you designed it.
I designed it because a lot of people can't afford the rotary axis on a very low-cost product or a one-off, and we're doing exactly the same. We need to make small one-offs at odd angles, and so these are the products that do it.
If you've got one hand free, can you just illustrate, and show how this actually rotary axis works?
What we have here is effectively a 90-degree rotary positioning unit and an inclinometer. The inclinometer you set to 0 or whatever angle you wish. No need for a sine table. Find your angle, lock it off, put in your part,
and off you go.
Vice, and you're away.
So effectively, by the looks of this, and we'll have a look at this also in the machine tool, it's a very modular system that is very repeatable as well in regards to everything is on 0 point.
Everything's on 0 point. Here you have a 0 point unit, and it can also reduce your Z-axis for very small tools. It's got a rising block on the back of it, so it tips over at 90 degrees. But with this, you can use it as a combination. So this can be used in with here. We can use 2 of these units together to get compound angles. Any angle that you can find on a 5-axis, we can achieve here.
And this is a very innovative and new system. You've designed it for your own workshop. You're a manufacturer as well as a seller. What difference has this made to your own workshop and your own manufacturing processes?
We don't have to go to the 5-axis, break down an expensive setup. We just put these on to our very simple prototyping machines, and we're away. We can produce whatever you like.
David, it's been a pleasure. Thank you.
Thank you, Geo.
Great stuff there. And I was making a few notes, and he beat me to it because he said about, I was thinking, it's a rotary table, why don't you have that? And he's obviously answered that question. 2 things though. He said he had one hand free. So how much was it? How much does the other hand cost? Come on. And Dave was obviously very excited about his product. It's a great product. But any more thoughts on that, guys?
Versatility and cost, really, and the ability to be able to not have to worry. Like a lot of companies that want to maybe automate, want to do things that they might look at the outlay being way too much in proportion or to the job that they need to do on it, and that's where it is. It's what value does it warrant to you invest to do a specific job? And with this, it's fairly a low cost way of doing angles and basically doing those jobs that you don't want to spend 30 grand on a rotary table for.
These are 25 grand. Yeah. No, I don't know how much are, but obviously cost effective solution. Geo?
I think that, echoing on what Paul says, really, I think it is a solution that enables you to make pretty much any component that you wish to make, dependent, if you wanted to have a 2-way compound angle, or anything that you can make on a 5-axis machine, you can now make on your 3-axis machine, prototyping, as Dave mentioned.
And he's a brilliant engineer. He really is. I've worked with David for many, many years. Really good guy.
Brilliant, fantastic. That's a great product. It really is. And so that's a multi-rad and multi-rise from Tame. Dave, it's his actual invention.
Yeah, great, incredible. He's invented so much stuff at Tame. Yeah, and he hasn't aged a bit since I sold him a machine 20 years ago.
Oh, not another person sold a machine to. Moving on very swiftly. Another fantastic invention. This was actually invented by Matt Genetti's father, Multilock system. This gives a great solution. Let's see our next video.
Matt, this is a perfect example of a work-holding solution for a 3-axis machine tool. Can you tell our audience about this solution?
Well, on this Hardinge Bridgeport machine, we've got the full Multilock table on the bottom, and then we've got a Nikon 4th-axis unit with a Multilock tombstone, 2-sided, designed to hold up to 28 components on it.
So 28 components. I'm assuming that's if you were loading it up with devices either side of the cube.
That's right, yeah. You can fit 7 rows of 2 vices, and then you've got the underneath as well.
And what kind of applications, what are you making on this solution, Matt?
Well, at the moment we're actually making the Multilock vice itself. We're making the front sliding jaw. It's a 2-operation job. The first operation we do on the vertical machine in the hydraulic vices. On the second operation, we're machining the front, and then we tilt it to put the angle of the sliding jaw on it.
So not only are you presenting more components to the spindle using the cube and the 4th axis, but you're also getting adjacent side milling.
That's right, yeah, we're getting three-phase machining on each part.
And if you didn't use work holding solutions such as this, and I know it's your own solution that you sell, so you're kind of making Microlock with Microlock, would you be able to be competitive?
Well, you wouldn't know, because you'd have to do it in 6 different ops, and it'd take probably 3 times as long, so it would obviously make it very expensive to make.
What an absolutely fantastic product. And I've been out and seen these on loads of machines, and the engineers absolutely rave about it. A couple of quick points though. Is he been working out a bit over lockdown? Because I'll tell you what, you go back through the videos on MTD, I'm sure he wasn't that big a few years ago. So
Like a foot pump.
it's pumped him up. But great work holding solution. Guys, your thoughts?
This to me, the biggest area I think that isn't maybe expressed enough with the Microlock system, and I used to see it when I used to either sell machines, or even in fact when I used to sell this too, but used to find that companies would on their VMC maybe have a chuck where they'd have a cylindrical part, and then they'd have a vise where they'd have a prismatic part, and that could take up 400-500 millimeters, so it could consume the whole of a bed of a VMC, for example. With this, I know you can get lots of small parts in 28 parts, as he's talking about, on one table, or you can do one big large plate. But what you can also do is a series of different components, because of the way you can mix and match the locators, the clamps. You've got jaws that will hold round parts. You've got soft jaws you can machine. So you can suddenly go from maybe taking up 500 millimeters of a working table to just have 2 parts to a couple of 100 mil to have, a lot more parts in one place. And I think it's that element of flexibility that this system offers.
What about ease of use? Is it easy to set these systems up?
Oh, dead simple. There's like a tenon on the bottom. It's machined to your base of your machine, and you drop it onto your VMC. It's secured into place. It's not going to move, and then putting the clamps and the locators on takes a matter of seconds. It really is fast.
And how much material are they clamping onto?
I mean, literally millimeters, and you can still generate. I think it's something like, is it 2 tons of clamping force or something ridiculous?
Well, he could do that without a wrench, can't he?
The clamping force is significant, and
it's pull down motion as well, isn't it?
Yeah, they've got like wedges. The internal parts of the clamp are designed with like a wedge, so it gives you kind of a pull down action. But I think for me, Microlock is such a universal system without the 4th axis unit. So then you introduce the 4th axis unit to a 3-axis machine tool, and then you've got a Microlock column that you've got the 4th axis, the extra axis. It is massive, because now, say for example, if you only had a 3-axis machine tool, you can only machine profiles and holes. You could only hit the part vertically. But now you can get that adjacent side milling and still have that flexibility, as you mentioned, to be able to have multiple setups, to present so many components to the spindle, and to do 6-sided work. The only parts you couldn't do on this, or your only limitations that you couldn't do, is 5th axis simultaneous machining, wow, that's it really. Or you're limited by the size of component you can hold. That's it. They're your only 2 limitations.
And these come in, they're modular, so you can have any size essentially.
Yeah.
Any size. So if you basically get in contact with Matt and the guys at Microlock,
do you know what he means when he says wedges? And it's not.
I'm thinking, what I'm having for dinner tonight. No? Okay, I think, 2 points. Flexibility, and it's another route to automation. It really is, absolutely. So moving on swiftly from Paul's bad gags, we're now going to throw to technical corner on a new innovation from Norgren work holding.
So Geo, the Adaptic soft jaw innovation. This is the first of its kind, isn't it? Tell us about it.
Paul, it's very innovative. I mean, this is a fantastic new innovation from Norgren, and as we've already touched on already, it's absolutely imperative to save setup time, especially on a 3-axis VMC, and I think that this new innovation is certainly aimed at that machine tool, and not only save setup time, but the saving of having to machine lots of soft jaws for your low volume work that you're putting through your 3-axis machine tool.
It's time and cost and everything, isn't it? It's holding them, it's storing them, it's space. But what gets me about this is how reliable and accurate's not the right word, but reliable and strong is this as a clamping mechanism?
I think it's more about, I think it's extremely strong and accurate, and it's fit for purpose. But for me, it's more about being able to hold them irregular shaped parts without having to machine soft jaws all the time.
But when you look at this, though, you've got areas of call it air there, haven't you, where you've not got a full grip on a component. Does it mean you can still get the kind of gripping force you need with security?
Better, Paul. That's actually better, because sometimes if you're doing a profile or machining soft jaws, the exact shape of the part that you're looking to hold, the irregular shape that you're looking to hold, what can happen is you can over-constrain a component. And what that means is when you over-constrain a component, if there is a slight high point on that profile of the part you're going to hold, you're effectively only holding on that one tiny little bit, and you're not getting the same clamping force. So having them gaps actually gives you more secure clamping force by not over constraining the part.
It reminds me a little bit of the matrix vice that ETG do with the pins, doesn't it? It's a similar sort of principle.
Extremely similar principle, Paul, and I think that this is the future, or part of the future, in work holding for 3-axis machine tools for sure.
And are they bigger and smaller as well? Because how would that work?
In regards to sizes and capacities, I'm not quite sure, but I would assume so. And I think that they would be made to accommodate for the majority of components and sizes.
That is a great illustration, isn't it, of what you can save? Because how many machine shops do you go in where you see these shelves stacked with these soft jaws, and they've got to find them, they've got to change them, and
floor space, Paul. But you know, when you look at reducing setup times, machining soft jaws is a big, massive part of that. Machining the soft jaws is like making a component or in itself. You know, the material costs of doing so, the storing of them. You know, this now is really game changing in respects to saving that setup times. Effectively now you can have any irregular shaped part, put it directly into this new innovation, and you're ready to go. You can use parallels underneath it to govern the amount of material that's sticking out from the top. So really exciting new product from Norgren. I'm really looking to see this in real life applications soon.
Wow, what a brilliant innovation. It really is. I mean, music to engineers' ears, really, because you can get rid of all those soft jaws, stick another machine in your machine shop.
Yep, you don't need all of those, all of those aluminium parts kicking around your machine shop. You can free up that space and put another machine in there.
At the moment, you can't get aluminium anyway, can you? So another great solution. Right, moving on. We don't need to say anymore because you covered it all off in your technical corner. So that finishes to the 3-axis milling section. So guys, some great products. Now, next is time for the horizontal machining solutions section. Geo, Paul, surely columns, tombstones, that's it?
A lot more than that.
A lot more than that.
Well, I think we need to ask the expert, so not you. Geo?
It is columns, tombstones predominantly, but you've got so many different variations of them. You've got dedicated columns, modular columns, 3-sided columns, 2-sided columns, 4-sided columns. So yeah,
when you say dedicated, bespoke ones?
Dedicated to a particular component. Well, that could be bespoke and be made specifically for that component, but it could be modular as well, that you just use the same setup, you know, for that component. But yeah, dedicated and bespoke columns are something that you would use for one specific component.
And I think with the horizontal, and I know it's a conversation and a debate that we'll have during technical corners and throughout the rest of it, but I often say people don't necessarily worry about the speed of changeover on a horizontal because they're doing it outside of the working area, generally because you've got a pallet pull or something, so the machines can still be cutting while you're setting outside. But yet a variety, myriad, plethora.
Oh, blimey, someone's swallowed a thesaurus, haven't they? That's not a dinosaur, by the way, Paul. So can I say pyramids? Is that another option?
Not really on a horizontal, no.
Right, there you go. So that told me, our expert, work holding solutions experts told me off there. So next we're going to a great example of a bespoke solution from Brown & Holmes.
So we've looked at many standard work holding solutions now for 5th-axis machines, horizontal machines and 3-axis machines. But what about when you need something special, bespoke, designed and manufactured specially to suit your application? Well, today we're looking at a bespoke column designed and manufactured at Brown & Holmes for a demo part that illustrates that it can be automated. Now, we have swivel clamps here. Now these swivel clamps will swivel into play. They'll position themselves on this face and all 4 of them will then pull the part back into position. But there's more to it than that. So I'm going to take the component off now and we can look at some of the features internally. So these are in play really just in case there is component deviation. Now this is what's called a pusher, and again this is hydraulically operated, and it will push the part onto the fixed stop on this side of the fixture. And this part here is a swivel and lock, I believe, which will come out and find itself and lock into position at the bottom of the component. But I'm going to talk now to Mark Haywood from Brown & Holmes to find out a little more. Mark, I say bath, you say bath, but what do you call this?
I would call that a touch and lock. I think in the catalogue they're defined as a work support.
Right, so tell me about some of the key features of this fixture.
Well, this is a demonstration fixture that Brown & Holmes has produced for demonstrating automatic loading and automatic clamping. The key features are what you would see on a lot of fixtures. So you've got 3-point location with a touch and lock or work support. You've got pushers to position the component, and then you've got swing clamps to lock and hold the component. Everything is sequenced, so we've got some sequence valves up the top here, so we can control that the pushers come in first, the touch and lock actuates second, and then maybe the swing clamps, and then an applied gripping force. All internally piped, so all of the system is hydraulically piped through the block with a main feed.
And what solutions would this provide?
I mean, this is more driven around a high volume, high production rate fixture that would perhaps go on a twin pallet system on a horizontal machine. And it's for quick loading of components, accurate and controlled work, holding and location of the component.
It's giving you repeatability?
Yes, yeah, very much so. Good clamping forces so that you can work the component hard and get the cycle times that you're after.
And I mean, this has been designed to accommodate for a demo part.
Yes.
But you design and manufacture these fixtures to hold parts that you just can't hold in standard work or with standard work holding solutions.
Yes, yeah. All of our bespoke work holding is driven by the application. So what the customer is requiring from that part, whether it's high volume, whether it's adaptive fixturing, whether it's ease of changeability, there's a lot of factors that we have to consider when generating a solution for a customer.
And we've got the pipe work at the back here, you can't quite see this, but how does the hydraulics connect to the machine tool? Is this a simple job?
It's all dependent on the machine tool. So if it's a single pallet, we can generally come through the centre of the pallet. Say for example on a 5-axis machine, we can have a rotary coupling to feed the requirements. On a twin pallet machine, we can have a overhead beam that can feed, or it can be a standalone hydraulically actuated fixture. So you would actuate it with a power pack. It would remain charged until you discharge the system when you're changing over components.
So lots of options.
Very much so, yeah.
And when we're talking about options, what about for 3-axis machine tools and 5th-axis machine tools?
Again, a bespoke solution is always driven by the application. So if it's a high volume part, this is an ideal solution. If a customer wants to maximise the bed on their machine tool, if they've got a large 3-axis, a truncheon setup might be ideal with a rotary table on one end and a slave the other, either giving you sort of multi-axis access to your components, or being able to put multiple components on multiple sides, so on a Toblerone 3-side work.
Geo, fantastic solution. A couple of points. I've been making notes, be going along because I am learning all the time. Absolutely, because you are the work holding specialist. First of all, love the way you work that camera, Geo. Those little looks, that's great, great stuff. Also, you preempted. You sort of peaked a little bit too early. That happens occasionally. You said about the 5th axis section, but that's coming soon. Again, moving on swiftly though, guys. Modular system versus a bespoke or dedicated system. What are your thoughts?
Well, this is engineering at its best, isn't it? When you look at fixture making, what goes into the design of it, all of the things, the permutations of what you have to put where, and like we're talking about, the work supports making sure components are level, they're secure, you're clamping in them in areas where you're not going to get collisions with the spindle. And the wear, if things are going to wear on clamping systems, can they be replaced? Yeah. This to me is what engineering is about, and this is when you look at the companies like Brown and Holmes, and there are others as well, like Highfall, for example. You go in their workshops and you see, fixtures being made for the automotive sectors that will be in machines, and they will be, under duress for 24 hours, 7 days a week, and they're geared and made to be able to perform in those environments. And I think when people talk about underestimating engineering and expertise, this is something you really do need to be, a skilled engineer to be able to achieve.
Question to you, Joe. Some of these parts, could they 3D print them? Or would they 3D print them?
The actual parts that they're manufacturing?
No, for the actual fixture itself.
Oh yeah, absolutely. Yeah, 100%. I think that they're already starting to 3D print parts for some of their fixturing.
Right.
So yeah, it's a good point. I think mentioning other companies, SNW, Telbrook as well, that supply specialist and bespoke fixturing such as this, and I completely agree. I think we talk a lot about stable process and about making a process foolproof. That fixture, really, when you're loading that part, you can't load it incorrectly.
No.
It will pull it back to the datum points, and it will apply exactly the right clamping force, and it will present the component exactly to the spindle as required.
And I like that's for horizontal. We're obviously talking about the horizontal sections, but if you go into Brown and Holmes, you'll see sometimes fixtures that might be 1 metre or 2 metres in size, and there's so many facets and areas to them, and you just think what goes into the development of these projects is second to none.
Amazing.
What's a Toblerone?
Well, don't you always get one when you go through an airport? That's the only thing you ever buy in an airport. But this is key to some of the points in this show. Your repeatability, your accuracy, getting rid of chatter or vibration, everything like that. So keeping that spindle turning. So another way of helping that automation, essentially.
Absolutely. 100%.
Stable processes.
Stable processes. Well, let's hope the horse hasn't bolted, eh? Anyway, moving on. I think I've got that, about your modular and then your bespoke system. So I've done a little elevator pitch. So what is the difference between a dedicated or bespoke work holding solution and a modular system? Well, a modular system is really one that's off the shelf. You can use it for any type of component essentially, and you'll be using it for one component in the morning, a different component maybe at lunchtime, and another component in the afternoon, and you could be doing small batch runs, big batch runs, and changing up all those different components. Now a bespoke one, yes, you're going to have to invest in that certain work holding solution, but over a longer term that will give you a better return on investment, because what will happen is potentially you get a better clamping force potentially because it'll be built around that component, but you might be able to bring it down from 3 ops down to 2 ops as an example. You might have a recess in the tombstone so you can actually machine where you couldn't with a standard modular work holding solution. You are going to invest more, but the return on investment over a period of months or years will be much, much higher. So there you have it. Modular systems off the shelf, bespoke systems specific to that application. That's it, nice and simple. Guys, what do you think?
I would never want to be in an elevator after you, knowing what you do in them. that would be
very
my
accurate.
sentiment.
Look, I did my best, guys, but what we're going to do now is we're going to move on.
It needs cleaning.
Oh dear, come on, this is going out to the world, so don't tell them that, please. A flexible solution, and this is from Multilock.
This is a super work holding solution for a horizontal machine tool, and I have the pleasure to be back at Multilock to have a look at this. And now you can just see that the columns are actually just rotating around and one's being fed into the spindle. Matt, can you tell our audience about the solutions that you offer for horizontal machine tools?
Well, these are cubes we made for ourselves, for our own application. It's an H plus 300 Matsuura horizontal machine, 5 pallets. We've got 5 identical pallets, but again, that's what suited our requirements. We can make tombstones or whatever to suit your machine. So the standard horizontal sizes are 300, 400 and 500. This is a 300 pallet. As you can see, we've got 3 subcontract jobs up here that we're running at the moment. But we use it mostly to make Multilock, but that tends to be more through the night because the batches are longer and bigger, and so we set it all up before we go home and it will run through the night.
So for people that are unaware or that have not seen this UK manufactured work holding solution, what are the main USPs of a Multilock column?
The main ones are the flexibility, so being able to hold very different size parts and being able to change that quickly. The other one is the fixed jaws here are tenoned onto the cube, and that gives you a location of the workpiece, so you always know where your part's going to be relative to the cube and the machine.
So you've got lots of flexibility in regards to the movement of the jaws and the fixed jaws and the moving jaws wherever on that cube. And approximately how many parts could you hold on the column at once?
Well, on one of the jobs we do, we actually get 12 parts per face. So you imagine if you had 4 faces and 5 cubes filled up with that part, you could get a lot on there.
So Matt, with this kind of flexibility, it comes down to being able to move the vices wherever on each cube to suit the particular parts that you're manufacturing. And just one last point really, Matt, can you also do low volume work with this solution as well as high volume work?
And we do all the time. Most microlock batches are probably 100, 200, but subcon batches tend to be a bit lower, 10, 20, 50. So we try and do the subcon work during the day and the microlock at night.
And last question really, Matt. I can see that you're holding kind of predominantly prismatic parts, but what about holding irregular shaped parts? Is this an option?
Yeah, we do soft jaws in aluminium or steel. You can even put 3-jaw chucks on there and stuff like that, so it's completely flexible.
Wow, first of all, I'm going to say, sun's out, guns out. What's going on there? And he's getting a bit of airtime, old Matt Jeunesse from Multilock, but great system. So, guys, over to you.
I like the horizontal setup here with a pallet pull. Okay, you're looking at a very production orientated type solution there, but you could have with the cubes like this, you could have a different style on each pallet potentially, set up with lots of different components on pallet 1 to pallet 2. So the unmanned run can not just be about one specific part, it can be about a multiple of different components that might make up an assembly.
Brilliant. But also, a couple of key points are coming out from this. Again, you've mentioned your flexibility, repeatability, accuracy, no vibration.
But also utilising the machine envelope. With these microlock columns, we've mentioned utilisation of the machine envelope. These are being made specifically to suit a machine tool type. So not only for the Z stroke or the Y-axis stroke, shall I say, on the horizontal, but eliminating the dead zone at the bottom for where the spindle comes at the bottom and your swing diameter. So when designing one of these fixtures, they are standard to a certain degree, but they can be made bespoke to suit not only a machine tool type to get use the best stroke of that machine tool, but also the application of the end user.
Right.
What's the dead zone, Colin?
The dead zone. I'm just moving on. I will give you an answer, but I have to be off camera, I'm afraid. So, guys, I am going to stop you there. So, a common theme so far is, as we said, setup time reduction, flexibility, accuracy, spindle uptime, and repeatability. But let's now go on to the technical corner and see how all this can be achieved from one system.
So, Geo, 0 Point systems. This one from Hoffman. Can you explain how it works?
Yes, Paul. Paul, 0 Point systems, for me, are the future of work holding. And in this particular scenario, it works by using the pull stud. Now, the pull stud is the part that will fit into whatever work holding solution that you're looking to put onto your machine tool. The base is, well, there's different configurations of 0 points, as you'll see, dependent on what machine tool size and type, but the base has got the housing for the pull stud. The pull stud will be pulled down, as you'll see here, and it will repeat within microns. So it will give you ultimate repeatability and accuracy and save a lot of setup times too.
Yeah, I mean, what I like about what we're seeing here is the variety of shapes and sizes and pots, if however better word there is to describe them. So it means whether you've got vices, whether you've got magnetic tables, all of these can be basically attached, can't they? And it's very repeatable when you're lifting off and putting a new one on.
100%, Paul. So, if we look at it how it was done before, so let's have a look at the pain points that people would have incurred before. If you were doing a lot of changeover work, so you were doing different work every day, you'd be having to manually bolt these work holding solutions to the machine tools. You'd be continuously having to set up the datums, reset the datums, and so on and so forth. With this system, it's completely repeatable. You've got universal datum points. Say, for example, you're putting this setup on one day and then you had to repeat that setup in a week's time. It will go back into exactly the same position within seconds.
And what about within the tolerance? We're talking microns here.
Microns, Paul.
Repeatability.
Yeah.
What I find interesting about what we're seeing here as well is the horizontal element, or the horizontal machine element, where you've got the tombstones. To me, I don't see that very often on a horizontal machining centre. Why is that?
Well, we should be seeing it more often. I think but we should be seeing 0 point solutions more often on 3 axis, 5 axis and horizontal. And this is part of the reason of this technical corner really, Paul. In regards to the horizontal, you know, having that 0 point capability per face, for me is an absolute game changer again. And I know some people will say, well, you know, you're setting on the second pallet anyway, so you're not really saving setup time, and that is absolutely correct, you're not, but you're getting some of the massive benefits. Again, repeatability, you know, and accuracy, pull back force,
access to more access to the full face rather than having jaws over it.
Absolutely, especially if you're actually, you know, putting the pull tool directly into your billets and then loading the billets directly onto the column. It's absolutely a massive point, that is, Paul, because you're getting full accessibility. The part isn't being held, so you're getting better rigidity, eliminating vibration, and we've touched on vibration a lot, and that is so key.
Vibration. The thing for me that strikes these, even if you weren't looking to achieve the ultimate in precision, it's the speed of change. It's the fact you're doing it off the machine. You're setting off the machine, changing over the vices or whatever you choose to do, basically. But what's the mechanics behind how it works? It's okay dropping a vice on there, but how does it secure it?
So with this particular system here, it's used 5 bar compressed air, and it's just literally an on and an off, basically, Paul.
Right, so 0 point systems seem to be a common theme. Is this how, or is now essential for machining?
I would say, yeah, 100%. Definitely, yeah.
Speed and precision.
Yep. Couple more themes that we're hearing over and over throughout this show, which is absolutely essential. Okay, so there you go. It's back to Geo 2 minutes. He's going to give us a quick 2-minute summary of that section.
This nearly concludes the horizontal section, but before we move on to the 5th axis section, let's take a look at this solution available from First MTA, the Chick Multilock. Now this is a really versatile and flexible solution. It can be used in single station mode to present one large component to the spindle per face, utilising the capacity. It can be used in dual station mode to present 2 components per face to the spindle, or it can be used as a 0 point pallet changer, and you can present as many components as you can fit onto the pallet to the spindle. And I'm sure you'll agree, this is a very flexible system. Now let's move on to the 5th axis section and start with Heimbach. This is a solution that you wouldn't necessarily associate with a 5th axis machine, the Heimbach Manic, and you can present very large components, prismatic parts to the spindle with a colic chuck by simply prepping the billet.
But there you have it. That's the end of the horizontal section, and what you mentioned earlier, we're going on to the 5-axis solution. So how can you save time, money and increase efficiency on a 5th axis? Over to the expert and Paul.
Well, we'll go with the expert then, shall we?
Absolutely.
I think for me, in my opinion, you know, how many times do we go out and see 5th axis machines in use and they're only presenting one component to the spindle in most circumstances, and that component isn't kind of big enough to utilise the full capacity of the 5th axis table. It's a small component presented to the spindle on quite a large 5th axis machine tool. So for me to get or maximise efficiency on a 5th axis machine, I would definitely say present more components to the spindle.
Yeah, and you can do that. There's lots of systems which I'm sure we'll see in this show and throughout the MTD channel where you can get more parts on a table. Again, it comes down to part security, making as many of the faces available to be machined in a maximum area.
Absolutely, gentlemen. Thank you very much. So let's go to a video from Brown and Holmes.
So we have many work holding solutions for 5th axis machines, but they've certainly evolved over the years, and this is one of the most common, Eccentric Gripper. What is an Eccentric Gripper and what solutions does it provide? Well, it is what it says really. It centralises the part into the middle, so you haven't got a fixed jaw. Both jaws move and centralise the part. On this particular example, you can see high jaws here, and this is to give the part more clearance when the table is tipped over. So when the spindle is coming down and hitting this part, this is just a demo part which has got an internal 3D form inside, but some of the features of eccentric grippers you'll see quite frequently is where they're holding on just 3mm excess material and have snap-off features, but a very good example of eccentric gripper on a 5th axis machine tool.
So there you have it, a great example of only one component in the machine, but he said they're high jaws. I thought he said high drawers. I thought he was talking about one of my ex-girlfriends. I had a bit of a panic there. But anyway, moving on swiftly. We were discussing earlier about they only had the one component in there.
Yeah, I mean, this is an example of eccentric gripper really, and we're going to be moving on to examples of how we can present more components to the spindle with the high jaws. They are particularly high jaws, and why they're there really. A lot of 5th axis work is done when the table is actually at 90 degrees, not at 0 degrees, and you've got then extra y-axis stroke, and you've got better z-axis accessibility to that part when it's rotating. So them jaws are actually there, so the spindle is taken away from the actual machine bed when the machine bed is at 90 degrees, if that makes sense. So
absolutely,
it's all designed because that particular unit is bolted directly down to the machine bed. It hasn't got a riser block to give the actual clearance. The jaws are giving the clearance. But we're going to be moving on shortly to look at other solutions and to kind of show a work holding solution, but now how we can maximise the efficiencies and on a 5th axis machine. Because you imagine, like, you know, guys, that component, you could be making 3 of them on that particular machine tool.
Okay, hold on a second. Hold on. Yeah, I was just imagining 3 components on there.
You weren't still imagining about your high drawers.
Meltdown.
I want to know more about that.
No, you don't. We'll do that. I think no one needs to hear that, so I'll tell you that.
It's like
off camera.
shelves and drawers.
No, don't even go there. Just let's move on. So, okay, let's look at what you mean by modular system for 5 axis and being flexible. Well, first thing that stands out there, guys, is how fast was he working? Blimey, that's keeping that spindle turning. Guys, what do you think?
What on this? I mean, it's interesting to see that all the options available. You know, obviously, to quote one of Geo's phrases, application specific. But on here, I've got a question for you, Geo. We often see these 0 point systems and systems where you can put vices on angles as well for 5th axis machines, so you can actually hit more than one part, can't you? Is that something that you see as an option to people? Because for me, the advantage to that is when you're just doing one part on a 5 axis, if there's 6 machining operations, that's 6 tool changes. Then when the part's finished, you've got to take it out of the machine and put another one in. Whereas if you had 4 or 5 parts, you might have to set it in order to get to all the right faces, but one tool comes in and it does that same operation on 5 parts. It's the same sort of, you know, method of reducing production time, chip to chip times, isn't it?
Absolutely, 100%, Paul. I think that the pyramid solution is definitely another solution that is a fantastic solution for a 5th axis machine tool, and effectively then you can present 3 eccentric grippers to the spindle, and when you've got the machine tool orientated in a certain way, you can still hit all of the
You can still
sides.
hit all the faces,
Yeah,
so there's no
so
restriction.
There's no restrictions whatsoever. And even better, you can actually put a column on a 5th axis machine tool. There's not many people that actually do this, but I've done it before in the past. So you've got to be a bit conscious of inertia, because obviously the further you're sticking out, if you started to put forces at the very end, you kind of, there's an inertia forces, and obviously you can't have a tailstock. but you can have cubes that you
I
can
have
put
seen
onto.
5-axis machines with tailstocks.
Really?
Have you?
Yeah, I have. Yeah, I have
Well,
seen that.
I
Yeah.
don't know how you'd have to kind of. There'd have to be a
I'm
configuration.
just trying to think where and have seen it, but I know what you mean.
But you'd have to put a
We
hole
haven't got
there
long enough
to
for
get
you
the
to- we haven't got long enough for you
tailstock
to
on
do
there.
Yeah.
But with that configuration, then you're effectively got 4 eccentric grippers, presented to the 5th axis.
You're turning it into a horizontal machine then, though.
But
Almost,
you've got
like
5th axis
as well,
capability
yeah.
though, so you can still. You've got that extra axis, like with the Matsaurus
expert.
5th axis machines
Yeah.
that they've got.
Yeah.
They a lot of them have actually got cubes on.
Yeah.
And they can be three-sided cubes or 4-axis cubes. So another good solution for a 5th axis machine that's not commonly used.
R&G Precision. There's a video on the channel. You might even be able to put an overlay on. They had a triax. I think it's a triax system where he had a multiple of parts going into his MX330, and you looked at it and you just thought, actually, there was about 10. The way it got it stacked and set on this system, we'll have to try and unearth that footage and put it over the top. But yeah.
Well, we didn't see it there. These guys do a pyramid as well.
I'm assuming so,
I'm
yes.
sure I've seen
Yeah.
that. Yeah. That's Gareth and the guys because they've taken overlaying
Yes.
agency a little while ago, haven't they?
Yeah.
Yeah, look at where you got the vices on the sides as well there, which is a little bit like what you're talking about. We just saw where you got a vice on either side of the tombstone, so you can.
Yes.
That's a little bit similar to what you're talking about.
Yeah.
But yeah.
Okay. Well,
And as you stack up, do you increase inaccuracies as you're stacking with 0 point? So if you've got 2 microns between the first place and the second, then if you then put another one on top, is that another 2 microns and another 2? I suppose there's a build-up, isn't
There's
there?
bound to be some kind of tolerance build-up, but it's absolutely minimal because these are all ground parts.
Yeah.
And, the repeatability of each one is within microns. So if you start with a micron, you might get to several microns by the time, but it's not going to be a lot.
Even then, it's only
going to be very minimal.
So again, we use that phrase: flexibility, repeatability, accuracy. Any more?
Do you know what inertia is?
No, I was concerned about that. That's me getting out of bed in the morning. That's a struggle. I'll tell you what. Anyway, moving on.
Need inertia.
I've done something to upset you today, Paul. Anyway, I think we should move on to very rapid, not as rapidly as that, of course. So now let's go to a technical corner where we see a solution that lends itself to pretty much all machine tools. It's Blue Photon.
Now, I really love this one, Gio. This is so interesting. Blue Photon, talk me through how it works and who would use it.
No, thanks, Paul. I think it is really interesting, Paul. It's a fantastic innovation in work holding, and it is a very niche market in my opinion. Now, it works by using ultraviolet light to cure the adhesive on the grippers. Now, we'll see an example of this in a minute. This is just so
Did you get the security with that? Is it, and how long does it take for the adhesive to cure? All these things are the questions that come into my mind.
I mean, good questions, and it's a question that you probably get asked straight away. It depends how many grippers that you're probably going to be using effectively. Each gripper will have its own clamping force, pull down force. So if you were doing a smaller part, you'll only be using a few grippers. If you're doing a large part and covering a large surface
I suppose
area,
the more you want to grip, the denser you would have, more grippers.
Absolutely, but for me, Paul, in regards to what kind of applications that you would use it for me personally, it would be one of them solutions where you can't hold the part with traditional mechanical work holding solutions because you might distort the part and you might not be getting a stable process. And this is a solution of giving you a stable process for them really problematic parts that are so tricky to hold.
I mean, this one, it isn't possibly a part that would be tricky to hold. I get your point, but I find this quite interesting because how many occasions would people be looking to turn diameters where they've got chuck jaws that get in the way and then have to turn the part around and do the back end, and then you've got all the issues with it being the concentricity and all of that sort of stuff. But it's still a good example of using it on a mainstream application. We see here, once it's finished and they take it off, they have to then sort of chisel the adhesive off, don't they, as well?
Yeah, so there's 2 different ways. You can chisel it off, but they've also introduced a tool that can be put into the CNC to remove the adhesive too. So it can be programmed in. Once you've taken the part off, it'll go and clean the adhesive, which is a nice little touch. Also, especially if you're making more than one off. In regards to the turning component, I think that really
you know, if you're holding it with jaws, it could also distort the part, but by pulling it back, you're not going to get distortion, especially with ring work. And I think that is one of the keys to this. You know, you're looking at some of these really intricate parts. Again, this is probably not the greatest of examples, but the really intricate parts where not only is it really difficult to hold, but also if you did try and hold it, you might distort it, or you're not going to get good clamping force.
There was an example I know that Colin was talking about where there was a spine, and you imagine that sort of shape. How on earth would you hold that? You just can't do it in a way other than this, can you?
And I think it's an absolute and utter perfect example. You know, that is one of the best examples that you could possibly come up with. Or kind of imagine if you had a four-legged chair was a component and you needed to machine all of the legs of that chair, and it was a very kind of thin-walled looking component. You could put a gripper underneath each leg of the chair, pull it down and do your intricate machining on that part. So niche market, but it is definitely got a place in the market.
Colin said about the chair one as well, although those legs would need to be thick to accommodate his torso.
What a fantastic solution. As we said beforehand, pretty much any machine. I know it sort of doesn't sit with every type of component, of course, thin walls and things like that. But a couple of things you didn't mention in there, which I do know, the clamping force, let me just get this right, 200 kilograms per, what did you call it? Gripper, thank you very much.
Okay.
I should know that.
So if you had 10, you'd get 2 tons.
Yeah,
that's pretty good.
But then, as you alluded to, more force, more of the grippers, absolutely. And they will cure in 60 seconds. So your UV light on, 60 seconds, ready to rock and roll.
To its maximum strength.
Yes, absolutely. Yeah. So
no, I think it's a brilliant way to sort of conclude things. It glues everything together, doesn't it?
It does, and I don't think, and no disrespect to what you did in Technical Corner, it is getting the glue off is really, really. I did get that, but I ignored it. Let's just clarify.
That's the best one of the day.
Geo, off camera we talked about this. Don't encourage it, please. Absolutely. So there you go. But it is very simple to get that glue off. It's essentially just steaming it off with a cartridge or something, not a cartridge, but something not too dissimilar. So there we go. And I did notice in that Technical Corner there was a bottle of alcohol there. So were you doing a thing that wasn't actually used in the thing?
Was there a bottle of alcohol?
Oh, there most definitely was. It was empty. I think Paul was doing it. So there you go. So coming to almost at the end of the show, any final points from you guys?
I think it's been gripping, an absolute gripping exercise.
Please.
Didn't get that one either, did he?
I know it's been a great show, but I'm glad it's coming
I've had to hold
an
on
end.
tight with some of these gags and jokes.
Buckle up.
But for me, really, Colin and Paul, I think that for me, I hope that people have learnt something from the show. But ultimately, I think that it highlights that for your smallest investment, you can get your largest return of investment. And I think that over time, workholding has been overlooked. And hopefully, you know,
and I think we've obviously mentioned a few brands, but there's a lot of companies out there that we've done work with and do work with that offer similar solutions to these. I mean, there's so many options in the marketplace to explore that can give you quick, repeatable, precise work holding, which can improve productivity.
You mentioned about a survey off camera again. Only about 20% of engineers are using sort of suitable work holding solutions. Is that correct?
Not suitable, 0 point.
So
I think that 0 point, in my opinion, is something that is not used enough.
Yep.
And instantaneously, if people started to introduce 0 points onto all of their milling machines, their profitability will go through the roof. Their spindle uptime will increase. Their accuracy, repeatability, tool life longevity, spindle.
You've been reading the script, haven't you?
Yeah, but you know the benefits are absolutely massive. I can't stress enough the benefits. And I think if you're investing a lot of money into machine tools, if you want your business to be successful and profitable, you need to be investing in some of these solutions.
In fact, it's like a blank canvas, and you're like the Michelangelo in there with that work holding. Is that right?
The machine tool is the blank canvas,
yes.
And the work holding is the art.
Slipper pads, tombstones,
inertia,
and high draws.
High draws, absolutely. And if it is like a Michelangelo, I think Paul will be doing colour by numbers. There we go. I think we're going to bring a close to the show. So a big thank you to Les and Interco for sponsoring the show. So thank you very much for that. Thank you to our work holding clients for providing such great product. And last but not least, thank you for the viewers for watching. I hope you've enjoyed the show. Probably not the gags. And that's it. Swarf Talk, work holding solutions.